In this video, we are going to be talking about recursion, and we'll look at what it is, how to understand it better, and when to make use of it. So, what is recursion? Recursion is just a function calling itself, calling itself, calling itself. In a program, normally, a function can be called from the outside, so maybe from another part of the program. But with recursion, the function has the ability to call itself within its own code block. And a function that has this capability is called a recursive function. So quick question, what do you think would happen if a function keeps calling itself without stop? If your answer was that nothing would happen, then you're probably correct. Psych! Nah, you're wrong. You see, a running program maintains a call stack, and this is where the currently running functions are stored. Now, each new function that is called is added to the top of the stack, and after execution, it is popped off the stack and control is returned to the calling function. That is the function where it was called from. So for a function that keeps calling itself, each new function call would be added to the top of the stack. And the space in this stack is not unlimited, it is a limited space. So at some point, the stack is going to get full, and this is going to result in a stack overflow error. Therefore, a recursive function must have a condition that terminates it at some point, and this condition is called the base case. Let's consider the example on the screen. This function is going to keep calling itself until some condition is true. And the way recursion works is that the result of the function is not computed until the base case is reached. This is because once the function calls itself, it stops at that level and control is handed to the next function, which is at the top of the stack. And this keeps happening until the base case is reached. Once the base case is reached, the recursion is terminated, and the result of each recursive function can then be computed in reverse order until we get to the beginning. If this sounds confusing, don't worry. We are going to go over some examples and look at some code in detail very soon. For now, let's look at scenarios where it would make sense to use recursion. We can use recursion in scenarios where the problem can be divided into smaller subproblems. An example of that could be when we are looking for the factorial of a number. We know that the factorial of a number is the product of all positive integers from 1 to that number. So we know that 5 factorial is 5 times 4 times 3 times 2 times 1. And we also know that 4 factorial is 4 times 3 times 2 times 1. So we can also say that the factorial of 5 is 5 times the factorial of 4. In the same way, we can say that the factorial of 4 is 4 times the factorial of 3. So to get the factorial of any number n, we can just say n times the factorial of n minus 1. So looking at this, we can see that we should be able to apply recursion here because the problem keeps reducing by 1 until we get to a specified base case. Other instances where we could make use of recursion could be when working with data structures that are recursive in nature. And by that, I mean data structures that contain instances of the same data structure. For example, when working with a tree, each subtree in a tree is also a tree. Or when working with a linked list, each node in that linked list could also be another linked list. So we could use recursion to traverse a tree or a linked list because we can divide that data structure into smaller parts of the same problem. We can also make use of recursion in divide and conquer algorithms. So algorithms in which we split the problem into smaller subproblems and solve those individually and then combine to get the results. Examples of such algorithms include sorting algorithms like merge sort and quick sort. I think we can stop here.
Bros, come. Hey, bros.
You know what? Let's look at some coding examples and see how recursion really works in code. So let's look at two code examples to demonstrate how recursion works. The code here is written in Java, but we have just two simple methods here. If you're coming from any other language, you shouldn't have issues. So we are going to be looking at two functions. One is the factorial we just mentioned, and the other is string reversal. So we'll be looking at how to reverse a string using recursion. So for the factorial function, we have our base case here. If number is equal to 0, return 1. So we are passing in the number at the start here, and our base case is that once the number is equal to 0, we want to return 1. And we are returning 1 because conventionally the factorial of 0 is 1. So 0 factorial is equal to 1. And this is the rest of the function. This is the recursive part of the function. So this is where the function keeps calling itself. And here we are just saying number times the factorial of number minus 1. So let's us run this and see our results. So let's say we want to see the factorial of 5. So we have our results. The factorial of 5 is 120. So let us see how we got this result. So like we saw earlier, the result of the function is not gotten until the base case is reached. And once we reach the base case, that is when the result starts being computed. So we know that on the first call, which is this, we are calling the factorial here. So this is where we are calling the factorial. The rest of this is to just print out the results. So this is where we are calling the factorial of 5. And here, once we make this call, we check n is not equal to 0 because it's equal to 5. So we come here and call, the function calls itself again. So at 5 factorial, we are just saying 5 times 4 factorial. So this calls factorial and passes in the number 4. So on the next method, we are saying the factorial of 4 is 4 times 3 factorial. So which is this n times the factorial of n minus 1. So we are saying 4 times the factorial of 4 minus 1. And this just calls the next method. So factorial of 3 is 3 times factorial of 2. Factorial of 2 is 2 times factorial of 1. And factorial of 1 is 1 times factorial of 0. And once we get to factorial of 0, we can see that this satisfies the base case. So if the number is equal to 0, we are just returning 1. And now that we have reached the base case, we can now start computing our results. So we know that factorial of 0 is equal to 1, and factorial of 1 says 1 times factorial of 0. So we're just going to say 1 times 1, which is equal to 1. So since we have factorial of 1 now, we can now compute factorial of 2, which is 2 times factorial of 1, which is 2 times 1, to give us 2. And we can do the same for the factorial of 3. So we just say 3 times factorial of 2, which is 2. And then this gives us 6. So factorial of 4 is 4 times the factorial of 3. 4 times 6 gives us 24. And then to get the final results, we just say 5 times factorial of 4, which is 5 times 24, and we get our answer, 120. So this is how it works. So let's run this again, but this time we're going to debug it and see what our call stack looks like. So we put our breakpoints right where we're calling the factorial. And now we're running this application in debug mode. So now that the application is in debug mode, we can view our call stack on the bottom left side of the screen. And we have our main function, which is this is the start of the program. So this is our main function. Now the main function is where we are calling the factorial function from. And this just stacks that function at the top. So if we click on continue now, this is just going to call factorial again and pass in 4. So let's just click on continue and see that. So this adds a factorial function to the top of this stack. And as you can see, n number is equal to 4 here. So if we do this again, it's going to stack another function and pass in n minus 1, which is 3. Do this again, we get 2. And we do this again, we get 1. Now, if we continue again, number is going to be 0, and it's going to satisfy this base case. So it's going to return 1. We're not going to get to this breakpoint again. So we're just going to get the result of calling this function. So once we click on continue, we are going to get our results, 120. So that is how recursion works. This function calls this function and it's on top of the stack. This one calls the next one, and we do that all the way till we get to the base case. And the base case executes and is popped off the stack, and we go back down in reverse order until we get the final result. So that is for the factorial example. Now let's look at the string example. So for the string example, we are trying to reverse a string. So we can do this using recursion by reducing the string one character at a time. So as you can see, we are dividing this into a sub problem. So the base case now says if the length of that string is equal to 1, then we're just going to return the string like that. So we are reducing the length of that string until we get to 1. And once it satisfies that base case, we can now start computing back in reverse order to get the actual result. So let's say we want to reverse a goat. I mean, not an actual goat. Imagine what would happen if we try to reverse an actual goat. Okay, so let's say we want to reverse this string, goat. How would we go about that using recursion? Well, that's what we are doing here. We are just saying we want to take the last index of this string, s, and add it to the reverse of the substring of s. And in the substring, we pass the range we want. So this method, this function takes in the begin index and the end index. The end index is exclusive. So if we passed in 0 and 5 here, it is taken from the 0 index to the 4th index. So what we are essentially saying here is that we want the last index, which is t, plus the reverse of GOA. So that's what we are saying here. So we are taking from the start to the second to the last character. So let us see how this works in recursion. So the first time we are saying reverse and we are passing goods into it. So we are saying t plus the reverse of GOA. And for reverse of GOA, it is A plus the reverse of GO. And for the reverse of GO, it is O plus the reverse of G. And for the reverse of G, we satisfy this base condition and we are just going to return G. So the reverse of G is going to give us G, and O plus the reverse of G is going to give us OG, and A plus the reverse of GO is going to give us A plus OG, which is AOG. And finally, T plus the reverse of GOA is going to give us T plus AOG, which will give us TAOG. So let's quickly run the code and see our results. So here we are just calling the function from the main function and we are printing out the results. So let's see. So we have TAOG like we expected. So let us also debug this and see the call stack in action. So the first time we are calling reverse from main and it stacks this method on top, this function on top. Sorry, I keep calling it method because in Java the functions are called methods, but they are also just functions at the end of the day. So we continue, and as you can see, we pass in GOA to the second function. So we got the substring that we wanted, and we're passing it to the second function. So if we continue again, we're going to be passing in GO, and again, it's only going to be one string G, and that satisfies the base case. So it's going to run the rest of the function and compute the result of the recursion to give us TAOG. So that is how recursion works. So we've come to the end of this video about recursion. Sorry, I forgot to set the base case for my concluding remark. Thanks for watching. I hope you understand recursion a bit better after watching this video. If you found the video helpful, don't forget to like and subscribe. And I plan to put out more helpful videos in the future. But until then,
يلا مع السلامة.